Hey, I wanted to show problem 3 on homework 6A. Once again, we went over it in class, but we went over it kind of in a rush. So I want to go over it again just to make sure that it makes sense and everyone's able to get it. So I'm going to talk about this problem. So one thing we need to mention is that this rope is going around the perimeter. And the issue with this is we are on the shoreline, and I don't think I said that last time. So you can think of this as like the sea is right here. So we don't actually need to use any of our rope on this side because that's on the shore. All right. So we really just need it for whatever this length is. And then this would be the same. And then there's some other length that's longer over here. Now I'll make a rectangle. So it only has 3 sides. Now the perimeter normally of a rectangle would be 2 times that length plus 2 times the other length, right? But in this case, we don't have to deal with that shore, or we don't have to deal with one of the sides. We're missing a side. We're going to use the shoreline, or you could use the side of a building or something as a perimeter. So we don't actually need that. Your problem will tell you what your perimeter is. In this version of the problem, it's 1800. So here we have a single equation that can relate to X and Y. And this is a boundary condition. So we need to hold on to that equation right there. Now, what do we actually ask for? We're asked for to maximize the area with these conditions. So we want to maximize area. All right, well, what is the area of a rectangle? It's just length times width, right? So it's going to be X times Y. And that's still the dimensions, even though we have a missing side, that would still be the area of our rectangle. So we have the area, or just A equals XY. Now, because we have this boundary condition of we have this much rope, we can relate Y in terms of X. So Y equals 1800 minus 2X. So now I have Y in terms of X. So I have X 1800 minus 2X. So there's an equation for area, just in terms of a single variable. And this is single variable calculus. So that's going to be very helpful to us. Now, what's next? It says the length of the shorter side, length of the rectangular side. So we need to maximize this thing. How do you maximize a function? Well, you take the derivative and you set it equal to 0. Okay, and that will either tell you the max or the min, or both. Certain functions will tell you both. All right, but let's look at this. So that would be 1800x minus 2x squared. That's an upside down parabola. So that means when I take the derivative, set it equal to 0, that's going to tell me the maximum. Because this is an upside down parabola, it'll tell me some maximum. All right, so let's do that. Let's say dA over dx. And what would that be? Negative 4x plus 1800. Okay. Let's set that equal to 0 and solve for x. So a prime equals 0 is negative 4x plus 1800 equals 0. All right, well, that's just 1800 divided by 4. So we find that x equals 450. Okay. Now we have x equals 450, and you can see that as the answer is that one. Now, if x equals 450, what does the other side equal? Well, let's plug it in here and see what happens. 1800 minus 2 times 450. Okay. I get 900. So 900 should be for the other side. We see that that is the case. What is the maximum area? Well, way back when we found the equation for an area. So the area, actually, we can just use this equation, this will be easier. So that's 450 times 900. Divided by 405, 405,000. Okay. And then I suppose that would be yards squared since that is an area. All right, I hope that helps. And please let me know if you have any questions or any other problems you would like to see done.